Hi everyone, we are Team Char Wars, and our project is focused on validating a biochar's filter's capability to integrate with the ecofiltro system while removing arsenic to meet the WHO guidelines of 10 micrograms per liter while also minimizing cost. In Guatemala, large portions of the population live below the poverty line and access to safe drinking water is limited, especially in rural areas where water delivery systems are expensive. Ecofiltro is already a widely used low-cost filter that removes impurities like bacteria and sediment, but does not effectively remove arsenic. This is a problem as arsenic consumption is directly linked to health issues such as gastrointestinal problems, skin damage, and even cancer. Our solution is to use biochar as a filtration material. Biochar is produced through pyrolysis where biomass is heated in an oxygen-free environment at temperatures between 350 and 600 degrees Celsius. We use biomass sources such as crop straw and pine wood, which are both easily accessible in Guatemala. The result is a fine, porous powder with a high surface area that can absorb contaminants like arsenic. To evaluate biochar's performance, we used phosphate as a chemical analog for arsenate, and we ran phosphate solutions through column assays and measured the output with a colorimetric assay. And we tested a range of concentrations from 30 micrograms per liter up to 15 milligrams per liter. For the sorption testing, we used two main setups, a column pipette to simulate flow through the biochar by itself, and also a layered cuvette test where we layered in biochar with ecofiltro ceramic and activated carbon to test how it integrated with ecofiltro. During the colorimetric assay, we quantified the amount of phosphate in a given solution through the following process. This is a two-step reaction where phosphate reacts with molybdate to form a blue color, and the intensity of that blue color is measured by the assay, which corresponds to a contaminant concentration. Thus, we created a standardization curve using absorbance versus concentration, and we found that 688.1 nanometers was the best wavelength to measure concentration at. Then, from the column pipette experiment, we found that the 4 milligram and 15 milligram solutions provide accurate test results at 688.1 nanometers, while many of the other experiments did not yield such accurate results. Thus, we used these trials to run with the cuvette experiment, and we found that the biochar, in conjunction with the ecofiltro, increased the absorption by around 25 to 30%. Thus, now we move on to mechanical design. On the mechanical design, we developed two designs to integrate the biochar with the ecofiltro system. The first is an integrated biochar layer within the ceramic filter. This keeps the system simple and fully contained. The other is an O-ring seal design, which includes a biochar container, an O-ring for sealing, and a recessed handle for removal. Both designs ensure that water flows through the biochar without bypassing and do not complicate the ease of use of the existing ecofiltro. The impact of our solution is significant. It improves health by reducing arsenic exposure, reduces costs compared to water delivery or advanced filtration systems, and supports sustainability by using locally available water waste materials. What makes our solution innovative is how it combines a low-cost, widely available material with an existing filtration system in a gravity-fed, no-electricity design. Unlike conventional methods, this solution is practical for rural communities and requires minimal infrastructure or technical knowledge. Next steps include further synthesis and optimization of biochar and testing with real arsenic and ICP-MS as the gold standard, but our testing has found that accurate readings at 688.1 nanometers is the wavelength to measure at for a colorimetric assay, and that biochar successfully increases the arsenic absorption capabilities of the ecofilter design by 25%. Also, we suggest going with an O-ring design as is simple manufacturing as compared to the integrated biochar layer. Finally, we look forward as a team to see how biochar can save so many lives, not only in Guatemala, but also around the world. Thank you so much.